Today our topic is perpendicular bisectors and angle bisectors. So our learning target is how can I use perpendicular bisectors and angle bisectors to solve problems. First off, a perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So it's perpendicular to the segment and it cuts the segment in half. Equidistant is a point that is the same distance away from two figures. Alright, so theorems from your theorem resource sheet. Theorem 5.2, perpendicular bisector theorem. In a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So that's saying that on your perpendicular bisector, if there's a point, it's going to be equidistant or the same distance. So these two would be congruent right there. And then theorem 5.3, converse of the perpendicular bisector theorem. In a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segments. So just the reverse of the perpendicular bisector theorem. Example 1, use the perpendicular bisector theorem. Line BD is the perpendicular bisector. So right here, this is line BD, which means it cuts these two in half, makes the right angle. Find AD. Well, by the perpendicular bisector theorem, if there's a point on the perpendicular bisector, it is equidistant from the two endpoints. So we can say that 3x plus 14 is equal to 5x. So set those equal to each other. Solve for x, subtract 3x on both sides, we get 14 equals 2x, and then divide by 2, we get x equals 7. However, we want to find AD, so we need to plug 7 in here. Do 5 times 7 equals 35. So AD equals 35. Alright, next piece, key terms, concurrent lines, rays, or segments. These are three or more lines, rays, or segments that intersect at the same point. This point is called the point of concurrency. Theorem 5.4, concurrency of perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. So if you make the perpendicular bisectors of each segment, those are here in blue. They meet at this point, and this point is called the circumcenter, which we'll talk more about in class. But then that point is equidistant from all three vertices, so it makes these segments all equal to each other. Example 2, use concurrency of perpendicular bisectors. The perpendicular bisectors are in blue, and we want to find BG. BG right here. Well, if we know the blue points are the perpendicular bisectors, they all meet at that point, which makes all the red lines that I'm now shading in green the same. So they are all going to be equal to 9. So BG equals 9. Next piece is angle bisector. An angle bisector is a ray that divides an angle into two congruent adjacent angles. So it just cuts the angle in half, so it splits it into two equal angles. Angle bisector theorem, if a point is on the bisector of an angle, then it is equidistant from the two sides of the angles. So kind of similar to the perpendicular bisector theorem. So there's a point on the angle bisector then these two segments that I just drew in blue would be equal to each other, and then the converse of the angle bisector theorem is just the reverse. It's the opposite. Example 1, use the angle bisector theorem. Find the measure of angle GFJ. GFJ. So it's angle bisector. We know it's an angle bisector because these two pieces are congruent. So we weren't told that it's the angle bisector, but since we have that these two pieces are congruent, then we know that it is an angle bisector, which means that these two angles right here are going to be equal to each other. So the measure of angle GFJ is going to be equal to 42 degrees. Example 2, use the converse of the angle bisector theorem. For what value of x does P lie on the bisector of angle A? So if this was the bisector and P was on there, then these two pieces would have to be equal. So we want to figure out what that value would be. So we just set the two equal to each other. Subtract x from both sides, we get x equals, add 1 to both sides, 4. So x would have to be 4 for P to be on the angle bisector. Then the last piece, concurrency of angle bisectors of a triangle. So concurrency, remember that point where 3 or more lines intersect. So if you make the angle bisectors of a triangle, those are here in red, they all meet at this point. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So if we were to draw a side perpendicular to each side of the triangle from that point, then those pieces are equal to each other. And this is called the InCenter of the triangle. So using that piece, example 3, use concurrency of angle bisectors. Point D is the InCenter, which means it's the point where your angle bisectors meet of triangle XYZ. Find DB. DB would be this piece right here. Well, we know that all these blue pieces are going to be equal by the concurrency of angle bisectors theorem. So we know that DB is going to be equal to DC, which is 9. Alright, that is all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.